Assalamualaikum warahmatullahi wabarakatuh, and hi madam. We are from Group 5. We'd like to present about our project, which is Nasi Biryani Rocket Restaurant. First of all, let me introduce myself. My name is Narsafa Ali binti Ahmad Yusri from BITC S1G1, and my mention number is B032110087. And my group members is Nurul Emida binti Mazli, Karunisa binti Khairul Anwar, Nurul Sakinah binti Sahari, Aisyah Aida binti Arzlan, Nur Fajrina binti Abdullah, Nur Hidayah binti Rosman, and Azra Afza binti Azmi.
This video will explain about 5 main contents. First, introduction. Second, problem statement, objective and scope. Third, current logical design and future logical design. Fourth, current physical design and future physical design. And the last one, conclusion. Introduction. The company name is Nasi Biryani Rocket. It located at number 25 Jalan Kota Fashion 2, Melaka International Trade Center 25450 Aikuruh, Melaka. The nature of business of Nasi Biryani Rocket is food beverage industry. For the problem statement, Nasi Biryani Rocket restaurant does not have any network infrastructure in it. The restaurant itself does not have proper facilities such as the CCTV system and Wi-Fi network. Without such facilities, the restaurant itself will not be able to fulfill its business management and operation globally. Thus, without a secure network infrastructure within the restaurant itself, the manually implemented system can be introduced. Therefore, by prohibiting the restaurant from progressing in terms of its business. For the objective part, the first objective is to identify the network and infrastructure requirements of the Nasi Biryani Rocket restaurant. Number 2, to design a corporate local area network that meets the operational and communication demands of the organization. Number 3, to document the network design, including network diagram and IP addressing scheme for future reference and troubleshooting. This project scope will be focused on the areas of the dining area, cashier counter, and kitchen. This project will study and analyze the existing network in Nasi Biryani Rocket restaurant. The suggested area design for this network will be in the eating area, which is where they primarily conduct the business, and propose as an improvised version of the Nasi Biryani Rocket network. According to the interview, the Nasi Biryani Rocket restaurant does not offer Wi-Fi for customers in order to browse the internet, but instead use the private network to connect each device, such as tablet, when during restaurant operation. A suitable technology and topology will be chosen for this project in order to improve the designing process. All the network design requirement and request of the owner of Nasi Biryani Rocket to fulfill their function in this project. The equipment for this project should be under their budget and suitable for their function.
Okay, next about criteria of technology evolution. We have a composite flow, area, capacity, max capacity needed, delay, reliability, and user. So for composite flow, we have CF1 until CF5. For CF1 is FE and F hash. For FE, stock inventory system, and FH online food ordering system. In CF1, we have area is line and using capacity 25 MBS. For max capacity needed, we use 41.6 MBS, and for delay and reliability, we use 10 ms. For delay and reliability, all CF1 until CF5, we use 99.98%. And last, for user, in CF1 we use 64 only user. For CF2, it's between FB, FD, and FH. FB is payment system, FD is database system, and FH is online food ordering system. And for CF2, we use the area line and capacity 55 MBS. Max capacity we use is 91.67 MBS. And for delay, we use also 10 ms. And reliability all the same. For user, more than one from CF1 is 65. And next is CF3. CF3 is between FG and FH, is CCTV system and online food ordering system. And for CF3, we use area line, and capacity we use 25 MBS, same as CF1. And max capacity we use 41.67 MBS, and delay still 10 ms. Reliability same, and the user is increased is 118 user. And for CF4 composite flow, we use FJ, between FG, and FF. For FJ, network monitoring system. For FG, CCTV system. And for FF, web system. For CF4, we use area line. Capacity is 30 MBS. And max capacity, we needed 50 MBS. And delay also same with CF1 until CF4. And reliability same, and the user is 177. And for CF5, we use between FF, FK, FG, and FI. FF is a web system, FK is email system, FG is network monitoring system, and FI is domain name system. For CF5, we use area 1. Capacity is 40 MBS, and max capacity is 60.67 MBS. For delay, we use 18 MBS, and reality same, user is the highest 242 user. And we have also BB1 is backbone flow, and the area still LAN capacity 90 MBS, max capacity is 150 MBS, the delay is 80 ms, and the reliability also say 99.98%. And we have an example calculation of max capacity. If CF1, we use 25 per 0.6, and we got the max capacity. And for BB1, we using 90 per 0.6, and we got max capacity is 150. Okay, so for this part, we show that calculate the capacity based on the estimate crew from year 1% until year 3. That's for flow. For CF2, we have for year 0 is 91.67 MBS, and grow for year 1 21.08 MBS, year 2 24.75 MBS, year 3 17.42 MBS. And for CF3, also the capacity is 41.67 MBS, and then for year 1 9.8 MBS, and year 2 11.35 MBS, and for year 3 7.92 MBS. For CF4, starting for 50 MBS, and for year 1 we use 11.5 MBS, year 2 13.5 MBS, and year 3 9.5 MBS. And for CF5, 60 and 0.67 MBS, and this the increase here, the decrease MBS. For BB1 also 150 MBS, and decrease to 34.5 MBS, and 40.5 MBS, and lastly 28.5 MBS. And CF1 starting point for 41.67 MBS, and decrease until 7.92 MBS. There's also have a example calculation of user group for year 1. Every year is 10% growth. The example for CF1, how to calculate, and BB1.
I will explain about the process of identifying interconnection mechanism. The first step is determining the degree of hierarchy in the design that can be seen as the figure. There are one-to-one connection that indicate non-degree of hierarchy in this network business between server room and dining area, server room and office, cashier and kitchen, server room and store, and between server room and internet. That also two-to-one connection that is low degree of hierarchy between kitchen and server room to cashier. Lastly, there are 4-to-1 connection that is medium degree of hierarchy between store, office, cashier and internet to server room. Next step is determining the degree of redundancy. There is 1-to-1 construction of flows between ISP and the server room that indicate non-degree of redundancy. That means there are no alternate path. There are also 5-to-1 construction of flow between server room to cashier, dining area, kitchen and office that shows medium degree of redundancy, and there are only 1 or 2 alternate path and is unequal. Last step in interconnection mechanism is adding routers and switch to the network design. Router will be placed in the server room and their switch will be placed in between to allow the connection between server room to other places such as kitchen, store, office, cashier and dining area.
Next, for network management and security issue, based on this design, we can see the implementation of router and switches that consist its own IP address. Next, implementing security and security risk analysis for network and physical security. For network security, we implement a firewall, SNMP version 3, and user authentication. While for physical security, we implement an access control system, CCTV, and security alarm for our restaurant.
This figure shows the cable plan option for this company, which is centralized wiring scheme. In the server room, there are PP, patch panel, POP, point of presence, which is entry point of data to building, and MDF stand for main distribution facility, where the most complex hardware is centrally located here. All patch panels, fiber monitoring, and testing equipment can be operated from central location, which at server room. Centralized wiring schemes are also flexible in configuring addition to the cable runs.
My name is Azra binti Azmi. I want to present about addressing and routing strategy. This is our table of addressing, and our routing strategy is the selecting the appropriate routing protocol in the design. To decide routing strategy, we need to choose the proper routing protocol. Routing protocol consists of two, which are static routing protocol and dynamic routing protocol. Dynamic routing consists of interior routing protocol and exterior routing protocol. Our design will be selecting the routing information protocol and border gateway protocol version 4 that in dynamic routing. Next is routing information protocol. Routing information protocol is a vector routing that uses the hop count as the routing unit for finding the most suitable paths between the source and destination. Routing information protocol is chosen over OSPF because our design does not involve main router. Every time our network topology is changed, routing information protocol does not require an update, and it is easier to configure it. Compared to OSPF, RIP is guaranteed to support almost all types of the router. Next is border gateway protocol version 4. In our design, we choose the border gateway protocol version 4 since it supports classless interdomain routing. Compared to the protocol, border gateway protocol version 4 is used as the TCP connection for the router information exchange. This is increased and durability. If there is no error occurs, the connection will be not closed and is permanently use the same connection. Next, border gateway protocol information protocol version 4 use patch vector to control the router. The sequence of the autonomous system is called a patch or router, as can detect the loops and compare the length of the router. In conclusion, the project aims to design, obtain, and implement a network connection for Nasi Biryani ROKETRESTAURANT. The network infrastructure will enable the generation of accurate real-time reports, assisting and decision-making processes, and enhancing overall management, with the ability to monitor sales data, track inventory,
and manage staff attendance electronically. The restaurant owner can make informed business decision and optimize operation. Proposed network design take into consideration the current requirement and future growth of the restaurant. The scalability and adaptability of the network will allow for easy expansion, accommodating an increasing number of users adapting to any technology advancement in the future. The implementation of a comprehensive network infrastructure will transform NASI Brand Rocket into the technologically advanced and efficient establishment. It will streamline operation, improve customer experience, and provide a secure and connected environment for both staff and customer. With this advancement, and restaurant will be well positioned to thrive in the industry and meet the evolving demand of the customer.
That's all for us. Thank you for watching.